Hi and welcome back to the course. In this video and in the next, we're going to go over how easy it is to add more to our API and make it more powerful. We're going to do that by adding the concept of stores in this video. Let's go over to our models folder because we're going to start by creating a new model as opposed to a new resource. That is because the resource normally has to use the model to extract data from the database. The model kind of stands on itself. Let's right-click the models folder and create a store.py file. And what we're going to put in the store.py is a copy of the item model. So I'm just going to select everything there, copy it, and paste it in the store.py. Now, of course, we're going to change a few things here. We're going to call this StoreModel. The table name is going to be stores. It's not going to have a price column, it's just going to have an ID and a name. The JSON method is going to be slightly different. And that is going to be, instead of name and price, it's going to be name and items. And here, we're going to put self.items. And we're going to get into exactly how we get those items in a moment. Okay. The find by name is going to be exactly the same. We're going to be able to retrieve a store by its name, and then we're going to be able to save to the database and delete it from the database as well. So nothing there is going to change. Now we have to make sure that we have this self.items thing. Let's go to the item model first, and we're going to add something there. What we're going to add here is a new column on the item. This column is going to be store_ID. And this is going to be an integer because it has to match exactly the store's ID type. And it's also going to have something else, which is db.foreign_key. And the foreign key is going to be stores, which is the table name of the store.id, which is the column name. Okay, so what does this mean? What is a foreign key and why are we putting a store ID here? Well, let me show you a small diagram here. Imagine that we do have these two models, the item and the store model. If we create, say, 3 items and they all have the same store ID, which is 2, and then we have a store that has the ID 2, we can link them in our minds by saying that these 3 items belong inside this store, or they are somehow linked. And that is because we have the item, we have the store ID, and therefore we can then go to the database and find the store that has this ID. Similarly, if we have the store, we can go to the items table and find out which items have the same store ID as this store's ID. So if we have the store model, we can find all the items that belong to it. And if we have an item, we can find out the store that it belongs to. So they are somehow linked. And this link is caused or created by the foreign key. The ID in the store is a primary key, and the store ID in the item is a foreign key because it has values identical to the ID values of another table. In this scenario here, where we have 3 items with store ID 2 and a store with ID 2, we would not be able to delete this store. The relational database engine, such as SQLite or Postgres or MySQL, would not let you delete this store because there are foreign key references. So you'd first have to delete these items or move them somewhere else, change the store ID, before you can delete this store. So it allows us some degree of control and security in knowing that these two are linked and it's not just in our heads. So by using a foreign key, that gives us that security that we can't delete things, for example. Okay. So this is why we're adding this store ID to the model, because then we're going to be able to say, what store do we belong to? and we're going to be able to find the store. But there would be a way to do that with SQL, with a join. And we're going to look at what a join is in a future video. But we don't have to. We don't have to use joins because SQLAlchemy does all that for us. All that we have to do is now say store is db.relationship StoreModel. And voila. If you've ever used joins in SQL in the past, you'll be pleased to know that you no longer have to do that. What this does now is that it sees that we have a store ID, and therefore we can find a store in the database that matches this store ID. So now every item model has a property store that is the store which matches this store ID in its ID. So hopefully all of that makes sense. But also we can do a back reference. A back reference does the opposite. It allows the store to see which items are in the items database, in the items table, with a store ID equal to its own ID. And the way we do that is items equal db.relationship item model. How easy is that? Okay, so what that is doing is it's saying we have a relationship with item model. And then SQLAlchemy says, okay, there's a relationship there. What's the relationship? And then it goes into the item and it finds that there's a store ID here. And then it goes, aha, there's a store ID in the item, which means that one item is related to a store. Therefore, there could be more than one item related to the same store. There could be 2 items related to the store, like in this example, or 3 items related to the store. So it knows that the store in the item, this variable here, is a single store, i.e., there is only one store that an item is related to. But the items variable in the store can be many items. So therefore, if we go to the store, this variable here is a list of item models because it knows that it is a many-to-one relationship. There could be many items with the same store ID. So hopefully all of that makes sense. And now we can go back here into self.items and we can access each of the item JSONs. So what we're going to do is, as you know already, we're going to replicate what we had in our item list get endpoint. Item.json for item in self.items, and that's it. Now there's an important thing here that often goes overlooked, and that is that there is a relationship that has been created as soon as we create a store model. So if we have many stores and we have many items, whenever we create a store model, we're going to go and create an object for each item in the database that matches that store ID. Now, if we have very few items, that's fine, but if we have a lot of items, that can be a really expensive operation. So what we can do is we can tell SQLAlchemy to not do that, to not go into the items database, into the items table, and create an object for each item yet. The way we do that is we say lazy is dynamic. And now, whenever we access the JSON method, we're going to get an error, unless we use .all. So what's the key take here? When we use lazy equals dynamic, self.items no longer is a list of items. Now it is a query builder that has the ability to look into the items table. And then we can use .all to retrieve all of the items in that table. Which means that until we call the JSON method, we are not looking into the table, which means that creating stores is very simple. However, it also means that every time we call the JSON method, we have to go into the table. So then it is going to be slower. And what I mean with that is, we create a store, so we load up all the items, and then we can call the JSON method many times for free, essentially. If we use lazy dynamic, every time we call the JSON method, we have to go into the table. So then that is slower. So there's a trade-off there between speed of creation of the store and speed of calling the JSON method that you have. That you have to think about which one is more important. In our case, because the store model gets created when we want to access the data, it's going to be like that in our resource. I'm going to stick with this way of doing things. But just food for thought there, something that you have to take into consideration. Of course, something else we have to do is to go to the item model and make sure that we're accepting a store ID there as well, and saving that to the database. What that'll do is that'll make sure that the store ID for this specific item model we're creating gets assigned the value that we pass in, and that gets put in the database. Now that we're here, let's go into the resources and just make sure that we're accepting this as well, and we don't forget later. I'm going to copy the add argument and paste it in there, rename it to store ID, change the type to int, and change the help message to something a bit more helpful, like every item needs a store ID. Now, something else to remember is that whenever we create an item model, we're going to have to pass in the store ID. So for example, here in the post, we are creating a new item. The data that is parsed from the parseArgs method is now going to contain a store ID that we need to pass in. And similarly, down here in the put method, we have to make sure to include data store ID. I'll leave it up to you to change the store ID in here if you want as well, which you can do. Okay, also remember that data price and data store ID can be simplified to data. That is just going to do exactly the same thing. It's going to pass in price as data price and store ID as data store ID. So we can do that if you find that easier. Okay, so that's everything for this video. Now we've created the store model and we've linked it up with the item. In the next video, we're going to create the store resource. So I'll see you there.